Good evening. Welcome to this case study on braking system for centrifugal separator. We are all familiar about butter or cheese manufacturing. We know how it is done at home, right? The same when it is done in an industry, right? It needs certain machines, right? In butter making or cheese making, if we have liquid of different densities, it needs to be separated. For that, they use a machine called a centrifugal separator. And you see the picture of a centrifugal separator. It has got a feed pipe. It has an inlet pipe also, an outlet pipe also, and the separator is rotated at a certain speed. So in that way, the liquid of different densities are removed. And right, this is the arrangement that you have. And this type of equipment only, it is found in the dairy farms. And the main thing over here is the rotor or the rotatory part. The rotatory part is powered with an electric drive, which is made up of induction motor. So induction motor drive is being used here. And you may wonder what type of braking arrangement can be used for this type of separators, right? And that is going to be dealt in this case study. If we go with a mechanical braking arrangement, it can give us immediate braking, right? You can go with disc braking or a drum braking or anchor pin braking. You can go with any type of braking. But the thing is, the wear and tear of this product is very high. And if you go with the electrical braking, it can give a very smooth braking operation. But the type of braking that we use for this arrangement, it is a question. And we all know in a motor, we have three types of braking: regenerative braking, plugging, and countercurrent braking. And the same three braking arrangements are possible in induction motor also. In regenerative braking, we make the machine to run above the synchronous speed. In this case, if you make the machine to run above the synchronous speed, it's not possible because the rotor arrangement, it is a heavy one. It is a heavy metal body. We cannot make it to run at a very high speed. That is absolutely impossible, right? So regenerative braking is not possible over here. If you go with plugging, yes, in plugging, we can reverse the phases, right? With a phase reversal switch, we can implement this plugging operation. But the main drawback is when the phases are reversed, automatically the direction of rotation of the magnetic field also reverses. Then the direction of the rotor also reverses. Direction of rotation of the rotor also reverses. But here, when you have a huge liquid content and if the direction of rotation changes, it will lead to a malfunctioning. So that is also not possible. So the only thing is countercurrent braking alone is possible here. The countercurrent braking can be done with AC or can be done with DC. Right here, we prefer a DC braking arrangement. So when it comes to a DC braking arrangement, the DC current that is up, the torque that is produced with the DC current is going to counteract with the running torque of the machine and thereby braking the machine smoothly. A faster braking can be achieved. When the case of DC braking, we can very well use these steps. So first we need to calculate the starting torque. If the starting torque is known, then if we calculate the inertia of the rotor, then with these two factors, we can, keeping the time as a constraint, we can calculate the braking torque. And once the braking torque is known to us, the amount of DC current that has to be injected into the circuit can be calculated. And this curve can give you the idea, right? So the blue curve gives you the expected outcome, and the red curve gives you the expected like practical outcome, and with the variation in voltage also we can achieve the process. And the DC current, DC voltage that is required here, it is not going to be very high DC voltage, right? That's the main advantage with DC braking. Hope you would have understood the case study, and you'll be able to I'm sure you'll be able to take up this assessment too.